This is an AQA A-level chemistry question based around the topic of nomenclature and isomerism. Have a go at each section, pausing as you go, and then we can review your answers. Here's parts A and B, part C, and finally part D. In total, a 10-mark question. So going back to parts A and B, we've got compound J, leaf alcohol, and we've been given the structure of it. Produced in small quantities by many green plants, the E isomer of J is responsible for the smell of freshly cut grass. So you need to give the structure of the E isomer. Now you have to remember that EZ isomerism is geometrical isomerism. It's built around the spatial arrangement around the double bond. It comes from the German words Z zusammen and E entgegen, and that's together and opposite. So we need to start with our double bond. I would always have that at the centre and then build your four structures coming from the edges, so two from each carbon. Now, because I want this to be E, the easiest way for me to start it, I can see that each carbon in the double bond has an H on. So let's put those one above and one below the double bond. All you've then got to do is take the remaining parts of the structure and put those on. So I've got my ethyl group and I've got my CH2OH group going over here. Now, it's E because the higher atomic numbers, and it works with mass numbers as well, the higher MRs of these groups are on opposite sides of the double bond, but by opposite we mean one above, one below. Okay, moving on, part B, give the skeletal formula of the organic product formed when J is dehydrated using concentrated sulfuric acid. So we are looking at what we would make, what would change if we dehydrated it. Well, dehydration is the removal of water. It's the conversion of an alcohol to an alkene. So what we're going to end up with is another double bond on the end of the chain. Once you've got that and you've realised, you then have to draw it skeletally. If you do get stuck with skeletal formula, there's no harm in roughly mapping out the structure and then building the skeletal formula that we can see here. Moving on to part C, another structural isomer of J is shown below. We can see, explain how the Carn-Ingold pre-log priority rules can be used to deduce the full IUPAC name of this compound. Now, I think it's important to say that this is a very different wording to anything that you will see elsewhere. It comes from one of the specimen questions when the new A-level specification came out and the style of the exams changed. And the questions are certainly done in a different way. That's equally noticeable in the fact that as a 6 marker, the marking of this is unlike any other 6 marker. And as such, this is good to get some of the scientific detail, but it doesn't necessarily prepare you for the 6 markers that you would be facing now. But you can have a read through that, you can pause, have a look through, and you have got some good chemistry there to review. Moving on to part D, the effect of gentle heat on maleic acid is shown below. The student predicted the yield of this would be greater than 80%, so we're throwing in a little bit of amount of substance here. In an experiment, 10 grams of maleic acid were heated and 6.53 grams of organic product were obtained. Was the student correct? We need to do a calculation to justify it. So you can see we've already started here. We had 10 grams of maleic acid, and I've calculated that its MR is 116. From there, I get a molar value of 8.62 by 10 to the minus 2. Now, the mass of expected organic product. Because it's a 1-to-1 ratio, we know we would expect to make 8.62 by 10 to the minus 2 moles of the product. We can also calculate its MR is 98, and that means we would expect a mass of 8.45 grams. Now, we know we got 6.53, so we need to find out what 6.53 is as a percentage of the 8.45. We're finding the percentage yield. It takes us to 77.3%, and therefore the student was not correct. That takes us to the end of the question. Thank you for listening.